Hello everyone and welcome back to another mini concept, this time about Kirchhoff's law, or Kirchhoff, same thing. Um, there are two laws under Kirchhoff's law, and these complement and support Ohm's law as well as the other dynamics of circuits. And actually, if you use these laws or rules, you can actually double check your answers in even in the most simple of circuits, since this applies to everything. So first, we will understand the junction rule. But first, we need to draw a circuit so that we can actually visualize what a junction is. Oops. Okay, so let's start with the battery. And then we have a resistor here. Then we have nothing else. But here in the middle, we have one resistor. Okay, so this is our standard parallel circuit. A junction is any place that has three openings, or basically three lanes. So if it looks like a T or a cross, that is a junction. And this is because this allows at least three different directions of current to flow, for current to flow. So obviously there's one going this way, there's another one going this way, and then there's one to the up, going up. Or if it were going down, it would be this way, then this way, or going down. And of course, that's basically just the the simplest way you can describe a junction. So in this circuit here, how do we identify the junctions? Where are they? We can see that there's one junction here, there's another junction here. A T shape normally gives off a signal, or that's your signal that it's a junction. Now basically what Kirchhoff's junction rule says is that in any circuit, the amount of current that flows through a junction will always be equal to the sums of all of the current leaving the junction. So they basically add up to zero. And this makes sense. We know this because intuitively we can say that, okay, let's use this drawing up here. Let's say that I'm going to run current through this wire or something. I'm going to run it through here. It's eventually gonna go out this way, or it can go out this way. And that really just explains Kirchhoff's junction rule by itself. Because once the current leaves, let's say it's gone already, then the amount of current that's in the junction is going to be zero. And the sum of them, they cancel each other out, because the ones that go in, they went out, so they sum up to zero. And that's Kirchhoff's junction rule. Now, Kirchhoff's loop rule is a bit different. For Kirchhoff's loop rule, we have to redraw our circuit. We'll make it a simple series. A simple series that won't become so simple, because we'll end up having this. Two batteries. Now, what happens when we have two batteries? We can't just use Ohm's law, because this is already kind of complicated. I mean, we could use Ohm's law, but it definitely wouldn't be the easiest way to do it. For this, we have to use Kirchhoff's loop rule. And the loop rule basically says that all the electric potential differences, or all of the voltages inside a circuit, will eventually add up to zero. This is so that we can conserve the energy in the circuit. And this makes sense because you can't have it not be zero, because that basically means you didn't close your circuit. Because once, for example, let's say this battery didn't exist and this was just a line, my potential energy would be decreasing from the positive. So from here at the point of maximum potential, I'm going to be lowering it because I'm getting closer to the other negative side until it eventually drops down to zero potential energy, and then the loop continues. Now, this is basically a mathematical understanding of that. So for this video, we're not going to be explaining so much the junction rule, because that doesn't really involve that much math. Basically, we're just saying that whatever goes through that junction will leave the junction. And that makes sense. We know that. That's grossly simplified, but that's basically it, because the main focus of this video is the loop rule. So how do we use the loop rule? So first, let's assign values to our batteries and our resistors. So now let's assign some values to our batteries and our resistors. So let's give these let's give this a 20 volt voltage. Now wait, sorry, the battery here is flipped. It should be shorter. This should be larger. There you go. Okay. Now this can be 5 ohms and this can be 10 volts. This could be 3 ohms. Alright, so before we get into this, the most important thing about Kirchhoff's loop rule is understanding where to start. Because understanding where to start could make your life significantly easier. This is because Kirchhoff's rule involves assigning signs based on the direction that you're going around the circuit. Because as we know, voltage is based on potential difference. So from the word potential, it obviously can increase or decrease. And the farther we are from the negative, the more potential we have. And because the conventional flow of current is from positive to negative, we are continuously reducing our potential if we go from positive to negative. This is the conventional way of current. On the other hand, if we choose to go the other way, this would be a positive change in potential. So really it depends on you where you want to start. However, I prefer going from positive to negative so that we can follow the conventional flow of current. So, like I mentioned earlier, we can either go against or with the conventional flow. When we go with the conventional flow, we incur negative or loss in potential. So that means our signs for our voltage would be negative. The notation that we're going to follow, that's going to be essentially our basis here, is that the sum of all of our voltages are going to be equal to 0. So that basically will look like this. So IR1 plus oops, that's not an R. IR2 plus IR3 is going to be 0. And that's so on and so forth for how many ever resistors we have. So in this case, we don't know what I is, but we know what R is. And we're going in the negative direction. Negative in terms of potential difference. So we're going to assign a negative sign here. So for the first one, we can start here. First resistor. Negative I times 5. Because this is equal to voltage, right? And now we're going to move forward. 10 volts. Positive to negative, so we're still going to be minusing. Minus 10 volts. And then we're going to be moving forward. We're going to be here at this resistor. This one now. So we'll still be at negative I. So plus negative I times 3. And when we get to this point, we're going to be going from negative to positive, which increases our potential, meaning that we add 20 volts. And this should all equal 0. So let's try to arrange our numbers. Let's add like terms. So our I is going to be negative 5i plus negative 3i, that's just negative 8i, minus 10 volts plus 20 volts, which would be equal to 10 volts. That should be equal to 0. So what is going to be our I? We want to isolate I, right? So we can have 8i here is equal to 10. And further simplifying, we can have I is equal to 10 over 8 or 5 over 4. And this is going to be our current throughout the entire circuit because it's a series, right? Now, we can assign the currents there now. So we can put 5 over 4 amperes, 5 over 4 amperes. And we can start adding the voltages to see if they actually add up to 0. So let's get the voltage of the first resistor. The voltage of the first resistor is going to be IR. So V1 is equal to 5/4 times 5. And that's equal to 25 over 4. This is following this. So we're still going to have a negative sign. Negative 25 over 4. Now how about V2? we'll still have a negative sign, so that's negative 5 over 4 times 3. That gives us negative 15 over 4. So now if we add all of these up, we'll have the following equation. So we'll have negative 25 over 4 volts plus negative 15 over 4 plus negative 10 plus 20. 25, negative 25 plus negative 15 is equal to 40. 40 over 4, and that's equal to 10. So we're just going to turn this into 10 now. Negative 10 plus negative 10 plus 20 is equal to 0 volts. And that's how we know that Kirchhoff's rule works. You can use this for any circuit. You can use this for parallel, you can use this for combination, you can use this for series, just to double check your work. Of course, it's a bit of math, it's a lot of work. However, this is a surefire way to make sure that whatever values you got are actually correct. Especially applicable, this is especially applicable to circuits that have 2 batteries. This makes life a lot easier. And that's it. That's where the video ends. I hope you guys understood the Kirchhoff's law and his various rules. And that actually marks the end of our Physics 2 playlist for a while. I hope you guys learned something, at least from the last few videos. Thank you everyone for watching, and yeah, good luck for whatever exams or whatever endeavors you guys have. I'll see you guys in the next videos. Bye!